Hey you guys, you're watching the study guide video for chapter 12. So number 1 says, find the value of x. If necessary, round your answer to the nearest tenth. The figure is not drawn to scale. What we have here is we have a tangent to this circle, and then we also have this ray, this secant ray, going through the circle. And we see that they're intersecting outside of the circle. So to find this segment length right here, we're going to use the formula saying the whole segment, which is x, times just the outside part of the segment, which is again x, so we get x squared, is equal to this whole segment, 19 plus 9, times just the outside portion. The outside portion is 9. So again, what we used was the whole segment times the outside portion is equal to the whole times the outside. Alright, so the first thing we do is 19 plus 9 and we get 28. And then 28 times 9 is equal to x squared. And when we multiply that, 28 times 9, we get 252. And in order to solve for x, we're going to take the square root of each side. And it tells us to round our answer to the nearest tenth. So when we take the square root, I get x is equal to 15.87. And since I want to round to the nearest tenth, I look at the 7 and I round this 8 up to 15.9. So, wow, our answers here are not rounded to the nearest tenth. But there is this 15.87, so I'm going to go with that one. So B is my answer. And this is if it was rounded to the hundredth. Rounded to hundredths place. So these directions weren't really on spot for this problem. Alright, moving forward. Number 2 and number 3 say, assume that lines appear to be tangent are tangent. 0 is the center of the circle. Find the value of x. Figures are not drawn to scale. Alright, so assume that lines that appear to be tangent are tangent. So in number 3, we have these two lines that appear to be tangent. We want to find this angle x. It tells us that the measure of angle O is 130. So I'm going to put that in there. This is 130 degrees. Well, since I know that this measure is 130 degrees, and this is coming from the center of the circle, then this arc right here is also 130 degrees, because this is a central angle. So this arc is 130, and I know that a whole circle adds up to 360, so if I say 360 minus 130, I get 230, and that's going to be for this whole arc over here, equals 230. Well, since my tangents meet outside of the circle, I'm going to use the form that x is equal to 1/2 the difference of my arc. So 230 minus 130. 230 minus 130 is 100, and half of 100 is 50. So x is equal to 50 degrees. Looking at number 3, it's given to us that the measure of angle P is 16, so this is 16. We also see that this line appears to be tangent, and this line right here is obviously a radius since it's coming from the center of our circle. And we know from one of our theorems that a line that's tangent to our circle and it intersects at a radius, it creates a 90-degree angle. So this is 90 degrees right here. So that theorem again, it said if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. That was in section 1. So if we want to solve for angle x, well, we see we have this triangle right here, and we know triangles add up to 180. So all I have to say is 180 minus the sum of 90 plus 16. And that's going to give us x. So 180 minus 106. So x is equal to 74 degrees. And here's my answer for number 3. Alright, moving on to number 4. Number 4, it says that AB is tangent to circle O. Alright, and we see that we have a radius right here, so we know that at this A, it says BC is 72, and what we want to find out what's AB, so we'll call that X. Well, we have a right triangle, so we can use the Pythagorean theorem. We can say this side squared, so X squared, plus the other leg squared, so here's our other leg, so 28 squared, is equal to our hypotenuse squared. And our hypotenuse is this whole length here, so 72 plus 28 gives us 100 squared. Alright, so doing the math here, x squared plus 28 squared is a big number, 784. And that's equal to 100 squared, which is 10,000. Now solving, we're going to subtract 784 from both sides. And we get x squared is equal to, wow, x squared is equal to 10,000 minus 784 gives us, well, that's not it, 9,216. And to solve, we're going to take the square root of each side. So x is equal to 96. Alright, looking at number 5. Number 5 says JK, KL, and LJ, they're all tangent to circle O. And it says not drawn to scale. JA is 6. AL is 13. CK is 6. Find the perimeter of triangle JKL. So we want the perimeter of this big triangle. So we just need to add up each side, and then we have the perimeter. Well, one of our theorems says that if two segments are tangent to a circle from a point outside the circle, so here's a point outside, and we have two segments that are tangent to a circle, it says then the two segments are congruent. So that's saying this segment and this segment are congruent, these two are congruent, and these two are congruent. So that means that if this side is 6, then this side is 6. This is 6, and this is 13. So all we have to do is add all of this up. So 6 plus 6, that gives us 12, plus 13 plus 13, that gives us 26, plus 6 again, that gives us 12. Add all of that up. 12 plus 12 is 24, and 24 plus 26 is 50. So 50 is our perimeter. Alright, so let's look at 6, 7, and 8. Our directions here are to find the value of x. If necessary, round your answer to the nearest tenth. Alright, so in our picture for number 6, we see that we have this diameter here. And we don't have the whole diameter drawn, but we could draw it if we wanted to. And this diameter we see is perpendicular to this chord. And we know that in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. So that means if the whole chord here is 15, then this part is 7.5, and this part is 7.5, because it is half of 15. Now if I want to solve for x, I see x is representing a radius, and I could draw another radius over here and call this x, and that way I have this 90-degree triangle. And now I can use the Pythagorean theorem. So I'm going to set my legs 8 and 7.5. I'm going to find the square of those and then the sum and set it equal to x squared. So I know 8 squared is 64. I'll use my calculator to figure out what 7.5 squared is. And I get 56. Oh, sorry. 7.5 times 7.5 is 56.25. That's equal to x squared. When I add that to 64, I get 120.25. And to solve for x, I'm going to take the square root of both sides. So the square root is 10.96. And if I want to round that to the nearest tenth, well, the 6 is going to bring the 9 up to 10, and that's going to bring the 10 up to 11. So x is equal to 11. All right, let's look at number 7. Number 7, we basically have the same thing going on. We have this diameter. We have it being perpendicular to a chord. Over here, though, notice 12 is on the left. So 12 is not the whole chord. 12 is just half of it. So this other half is 12 also. And then x, again, is a radius. So we're going to draw our radius instead to enclose this triangle here. And we're going to use our Pythagorean theorem once again. So 9 squared plus 12 squared is equal to x squared. 9 squared is 81. 12 squared is 144 is equal to x squared. If we add these together, we get 81 plus 144, and we get 225 is equal to x squared. And to solve, we just take the square root. So the square root of 225 is 15, and that's what x is equal to. All right, let's look at number 8. All right, in number 8, we see that we have these two chords that are congruent. And we know that if you have congruent chords, then their arcs are congruent and their central angles are congruent. So the central angle here is 62, and that's congruent to x, so x is also 62. So 62 is our answer here. Remember, congruent chords relate to congruent arcs, which relate to congruent central angles. So arcs, chords, central angles. If we know that one of those three are congruent, then we know the other two follow suit. All right, in number 9, it says that WZ and XR are diameters. It says find the measure of ZWX. So the arc ZWX, we want to find this big arc right here from ZW to X. Okay, well, if we know that WZ is a diameter, then we know this whole arc right here is 180. So this is 180 from here to here. And then this arc is the only thing we need to find. And we know that the central angle is 48, and so the arc is 48. Because the arc and the central angle, they're congruent. So all we have to do is 180 plus 48. And we get 228, and that's equal to our measure of ZWX of the arc. So here's our answer. Number 10 says the radius of circle O is 20, and OC is equal to 13. Find AB. All right, so let's label some of this. The radius is 20, so here's our radius here. It says OC is 13, and we want to find AB. We want to find this whole length right here. Well, what we should do is use our Pythagorean theorem to find half of the length. We'll call half the length x. Essentially, though, we want to find the whole thing, so we want to find 2x, essentially. So once we solve for x, we want to times it by 2 to get the whole length of AB. All right, so using the Pythagorean theorem, we get 13 squared plus x squared is equal to 20 squared. 13 squared is 169 plus x squared is equal to 20 squared, which is 400. When I subtract 169 on each side, then x squared is equal to, let's see, that's going to be 231. And then I'm going to square root each side. So using my calculator, I get x is 15.19. So I'm going to round out to 15.2. And then since I need to times it by 2 to get my answer at the end, times 2, I get 30.4. So 30.4 is our answer. All right, number 11 says find x. X is this inscribed angle. It's made up of these two chords. An inscribed angle is made up of two chords and the vertex is on the circle. The arc that corresponds, our intersected arc, is 47. Well, the relationship there is that this inscribed angle is half of its arc. So all we have to say is 47 divided by 2. So in our calculator, we get 23.5. So that's what X is. Let's look at number 12. It says the measure of arc BY, so right here, is 38. So let's label that. It says what is the measure of angle YAC? So YAC. And you'll find that measure. Well, we know that since this is the diameter right here, and therefore this is a radius, anytime a tangent and a radius meet at a circle, it creates a 90-degree angle. So we know this is 90 degrees. And we also know that if this is 38, then its inscribed angle here is half of that. So 38, when we divide that by 2, we get 19. So I know this is 19. All I did there was say 38 divided by 2. So now to find our measure of YAC, it's just going to be 90 minus 19. So doing that math, 90 minus 19, we get 71. So 71 is our answer. All right, now let's take a look at number 13. It says find the measure of angle D, so this angle right here, if we know that the measure of angle B is 53. Now this one's definitely a tricky one. You have to realize that the measure of angle B is an inscribed angle. Therefore, we know that this arc measurement right here is going to be twice that inscribed angle. So this arc measurement is going to be twice of 53, so that's 106. We also know that a circle adds up to 360 degrees, so we can tell that this other arc from here all the way to here is going to be 360 minus that 106. So 360 minus the 106 gives us 254. So this other arc is 254. Now we want to find this measure of angle D over here. Since it's outside the circle, we can say that D, or angle D, is equal to half the difference of our arcs. So 254 minus 106. So the measure of angle D is equal to half, and we're going to do the difference there, 254 minus 106, and we get 148. And then half of 148 is going to be our answer, so measure of angle D is equal to 74. All right, let's look at number 14. Number 14 shows us that the measure of arc DE is 114. So let's mark that. DE, this arc right here, is 114. Measure of arc BC, this arc, is 52. Find the measure of angle A. So we're doing exactly the same thing, but in 14 it gives us all the information up front. So we can say the measure of angle A is equal to 1/2 the difference of 114 minus 52. So the measure of angle A is equal to 1/2. 114 minus 52 is 62. And then half of 62 is 31. So 31 is our answer for number 14. All right, let's look at number 15 and 16. 15 says find the value of x for the measure of arc AB equaling 31. So this arc is 31, and the measure of arc CD is 24. All right, well, since these two chords meet inside of our circle, then x is equal to half the sum of the corresponding arc. So 31 plus 24. So x is equal to half the sum. We add that together, we get 55. And half of 55 is 27.5. So 27.5 is our answer. Looking at number 16, says find the value of x. If necessary, round your answer to the nearest tenth. Alright, so in 16 we have two segments that intersect inside the circle. So what we're going to do is set their products equal to each other. So here's one segment, So we have the product of 6 and x, so 6x is equal to, here's our other segment, so our product here is going to be 7 and 24, so 7 times 24. So 6x is equal to 7 times 24, we get 168, and then dividing by 6, x is equal to 28. So 28 is our answer. In 17, we want to solve for x. It's given to us that AB is 18, that BC is 8, and CD is 7. Well, since we have two segments and they're intersecting outside of the circle, we're going to say the whole segment times the outside is equal to the product of the whole segment times the outside. So our whole segment here is 18 plus 8. So 18 plus 8 times just the outside. Just the outside is 8. And that's equal to our whole segment over here, x plus 7, times just the outside. And the outside is just 7. All right, so working this out, 18 plus 8, we get 26. 26 times 8, we get 208. And that's equal to, distributing over here, we get 7x plus 49. And then again, 7x plus 49. And to solve for x, we're going to subtract 49 on both sides. So 208 minus 49, we get 159 is equal to 7x. And then dividing it by 7, we get 22.71. And it goes on, but we'll round to the nearest hundredths. So x is 22.71. Alright, number 18 says write the standard equation for the circle. So you want to recall what the standard equation looks like for a circle. And that's going to be x minus h squared plus y minus k squared is equal to radius squared. So plugging in the given information in number 18, our standard equation will be x plus 8 squared plus y minus 4 squared is equal to our radius squared, which is 49. Alright, let's look at number 19 now. It said a satellite is 4,400 miles from the horizon of Earth. So horizon is talking about this distance over here, if this is where our satellite is. It says Earth's radius is about 4,000 miles. So our radius is 4,000, and this is another radius, so that's 4,000. It says find the approximate distance the satellite is from the Earth's surface. So we want to know this distance right here. Well, what we do have is a right triangle because a tangent to a radius creates this 90-degree angle. So we can use our Pythagorean theorem. So we get to say that 4,400 squared plus 4,000 squared is equal to, and this is going to be 4,000 plus x squared, because that's our hypotenuse. So we're going to say 4,400 squared and get a big number. And what we should do here, because we're going to have to write these big numbers out, is save this for our calculator. So what we want to do is get rid of the square on the right side. So we're going to square root this side and square root that side. So then we'll get the square root of 4,400 squared plus 4,000 squared is equal to 4,000 plus x. And then to get rid of the 4,000 to isolate our x, we'll just subtract that on both sides. So we'll subtract 4,000 over here. So in your calculator, what I want you to do is say the square root of 4,400 squared plus 4,000 squared, and that's all underneath the square root, and then subtract 4,000 from that, and that will be our answer. So plug that in, and you should get 1,946, and then it's 0.4, so we're going to round off to 1,946 miles as our answer. So try it in your calculator, make sure you get that answer. Alright, let's look at number 20. Number 20 says, segment NA is congruent to segment PA. So we're going to put little congruent marks on here. Says segment MO is perpendicular to segment NA, and segment RO is perpendicular to segment PA. Says measure of MO is 10 feet, and we want to find what PO is. So number 20 is actually combining a couple of theorems. One theorem says that if chords are equal distance from the center, then the chords are congruent. So we know chord RO is congruent to chord MO. So we know that RO is congruent to MO. The other theorem says sorry, I realized it cut off there. So the other theorem that I was going to say says that if chords are perpendicular to a diameter, then that diameter has bisected the chord. So this diameter bisected this one, and then this diameter bisected this one. And since they were congruent to each other, then each little portion, each half, was congruent to the other half. So half of 10 is 5, so PO is 5. Alright, let's look at 21. 21 is a lot like number 20. So BZ is congruent to FC. Also, BZ is perpendicular to CA. Also, FZ is perpendicular to DC. And we know that DF is equal to 30. Well, using the same theorems as before, we know our two chords here are congruent, and we know that they're both being bisected. So if we want to find the measure of BC, we know that's the same measure as DF, so our answer here is 30 inches. Looking at number 20, it says find the measure of BAC. So it's talking about this angle right here. We know that we have a central angle that's 70, and the central angle and its arc, its intersected arc, are congruent. So this arc is also 70. For inscribed angles, though, the inscribed angle and its relationship with its intercepted arc is that it's half. So half of 70 is going to be 35. So 35 is our answer for the measure of angle BAC. Let's look at number 23. Number 23 says the measure of angle R is 46. So this is R down here, so that's 46. We want to find the measure of angle O. Well, you should notice that they have in common this intersected arc right here, because we draw it out. Measure of angle R is made up of these two chords, so this chord and this chord. So its intersected arc is right here. And we know that for inscribed angles, the arc measure is going to be twice. So this arc measure is actually 46 times 2, which is 92. Now we want to find the measure of angle O. And the measure of angle O is this angle right here. And it has this same intersected arc. Well, this angle O is not an inscribed angle. It comes from the center of the circle. So it's actually a central angle. And central angles and their arcs are congruent. So the measure of angle O is equal to 92. Let's look at number 24. 24 says the measure of angle BAD, so this angle right here, is 46. We want to find the measure of angle BCD, so this angle right here. Now we outline each of these angles, so BAD, we see that this is an inscribed angle, and here it's corresponding arc, or its intersecting arc. We outline the other angle, BCD, that's another inscribed angle, and notice it has the same arc. So if we have corresponding arcs, then we have corresponding angles. So our angle is 46. In number 24, our two angles are congruent because they're both inscribed angles. Whereas in 23, even though they shared the same arc, they weren't congruent because one was an inscribed angle and the other was a central angle. Alright, last one, 25. In the circle, the measure of the arc BC, so this arc right here, is 98. Find the measure of BCP, of an angle. So the angle it wants us to find is from BCP. Alright, well you should notice that arc is the intercepting arc for this angle. And this angle is an inscribed angle. So all we have to do is 98 divided by 2. And 98 divided by 2 is 49. So 49 is our answer, and we're done with our study guide. So if you guys have any questions, come in before the test, get some answers. Otherwise, good luck studying. See you tomorrow.